Well, let's answer a few questions, and we're going to zoom in a wee bit more. We're going to determine all the intervals on which the graph of g is increasing. So when a graph is increasing, well, it's going up, which means its slope is positive. Let's use another word for slope. Let's call it derivative, of course. So what I really want to know is, where is g positive? This is what it's saying. Like, tell me the intervals where this is true. Well, g prime. What's g? Well, I'm not looking at g. I'm looking at f. But g prime is f. Okay, this is the big idea. What I normally do when I get a problem like this that has an integrally defined function, I'll crank this out over on the side. And any question they ask about a derivative, a second derivative, I have a reference point for it. Or if they talk about increasing, decreasing, concave up, concave down, I have a reference point for that as well. Okay, so g prime is positive, which means if g prime is positive, f is positive. So here's what I'm really looking for. I want to know where the function is positive. Let's reword that once again. The graph I have at the top of the paper, where is it above the x-axis? And the answer to that final question would be from here to here. That would be -5 to 5. So final answer, -5 to 5. Okay. Should we include the -5 and the 5? I say no. Others would put a bracket there and not even flinch, but you know, not a huge deal either way at this point. Because technically, actually, at -5, the graph of g would not be increasing. It would have leveled off, but that's beside the point. Determine all intervals on which the graph of g is decreasing. So again, let's reword it. If a graph is decreasing, its derivative is negative, which means in this context that f is negative. Again, g prime is f. We've been through that. So where is this graph negative? It is negative from -10 to -5, and from 5 to 7. Notice the -10 and the 7. Those are the endpoints. It looks like it would keep going, but it actually doesn't. And so we are going to slide up. The graph is decreasing from -10 to -5, as well as from 5 to 7. And we could get into arguments about the brackets on the -10 and the 7. I would say to you that at those points, the graph is neither increasing nor decreasing because it's the endpoint of an interval, because we don't have slope at the end point. That's why that's the way it is. Anyway, not a huge deal either way at this point, though. Determine all intervals in which the graph of g is concave up. Okay, concave up. If a graph is concave up, its second derivative is positive, which means second derivative is positive. So the first derivative is positive. So its first derivative is positive. Okay, well, let's translate that one more time. If a derivative is positive, then that means the graph is increasing. So one more time, one more translation. F is increasing. That's what I'm looking for. I want to know everywhere that this graph is increasing. That's really what it's asking. G double prime is positive, so F prime is positive. Well, okay, that's great. This is not the graph of F prime. But what I'm saying is, where is the slope of this thing positive? Here, not here, not here. So -10 to -1. -10 to -1. Okay, determine all intervals in which the graph of g is concave down. Again, that's the second derivative being negative, which means the first derivative of f is negative, which means that f is decreasing. Okay, if a function is decreasing, its derivative is negative, and that occurs, you can look at the graph and see it yourself. It is from 3 to 7, so from 3 to 7, the graph is going down. 3 to 7. And now we get to some tricky ones, okay? We have to justify our reasoning. Ooh, scary. Determine the x value of every relative maximum value of g in the open interval from -10 to 7. Justify your reasoning. Whoa, what? Okay. I have maximums and minimums. We've been through this. I have maximums and minimums everywhere the derivative equals 0, everywhere the derivative doesn't exist, or at the endpoints of an interval. Okay, hold those three thoughts in your head. I will say them again. We have maximums and minimums. Let's look ahead. We're dealing with the same questions, sort of, on number 6. We have maximums and minimums where the derivative of g equals 0. I'm just doodling some thoughts over here on the side. I need g prime to equal 0. That's fantastic. What that really means is f equals 0. That's what I'm looking for. Everywhere f equals 0, everywhere the derivative of g, because that's the function we're talking about, this function, f, is used to define another function. Okay, so when I'm talking about the maximum value of g, I need the derivative of g, which is f. Okay, everywhere the derivative equals 0, everywhere the derivative doesn't exist, the derivative of g would not exist anywhere that the graph of f doesn't exist. The graph exists everywhere. No holes, we're good, we're fine. Or at the endpoints of an interval, but I'm not allowed to count the endpoints of the interval anyway. So don't even be talking about -10 and +7, because just no, all right? I need to determine everywhere that the graph equals 0. We can have the same argument here if you want to draw the same thing, write the same thing, you can. I'm not drawing or writing. Same thing. So we have two possibilities. Possibility number 1 is here. Possibility number 2 is here. Okay? Our answers for number 5 and number 6 will include a -5 and a +5. Okay? X equals -5, X equals +5. Which one's which? We'll deal with that in a second. Okay. When I have a maximum value, I talk like this. No, here we go. Final answer. I need the derivative of g, which is f, to transition from positive to negative. Okay, picture this in your head. If you're going to have a maximum, you got this thing going on, right? That means your derivative was positive then negative. Your graph was increasing then decreasing. F is the derivative of g. Let's just start writing. F, the derivative of g, transitions from what to what? Okay, we want this graph, the graph of g, which we don't see, and we may not have much of a context for yet. We want the graph of g to go up then down and tell the x value where that happens, which means its derivative, which we do have a graph for, will be positive then negative. Okay, f, the derivative of g, transitions from positive to negative, where? At, okay, does f, which is g prime, does it transition from positive to negative here? Or does it transition from positive to negative here? It's here. Positive to negative. Original function, g, was increasing then decreasing at x equals 5. Similarly, same idea. I'm going to write the exact same thing, almost word for word. F, the derivative of g, and you're like, well, I'm writing the same thing over, because it's a good idea to get in the habit of wording these things and knowing what they're asking about. The people that grade this, if it was a free response question, would need to know that you know that f is the derivative of g, and you found a maximum because that graph of the derivative changed from positive to negative. F, the derivative of g of oh, just a comma. Oh my goodness, we have just a comma. There we go. Transitions from, okay, now we're looking for a minimum, which means the derivative will be negative then positive. Original graph would be decreasing then increasing. From negative to positive at x equals -5. There you go.